everyone. Welcome back to InternetReport's bi-weekly pulse update, where we keep our finger on the pulse of how the internet is holding up week over week. And what an interesting 2 weeks it's been. Today we'll be discussing some Twitter disruption, the aftermath of a ransomware attack, a software release that resulted in some DNS resolution issues, and how a quickly executed manual process lessened the pain for some concert goers in Australia. And of course, we'll also cover the global outage trends. With so many interesting things to cover, let's start with the download. My TLDR summary of what you absolutely need to know about this internet this week in 2 minutes or less. Twitter experienced 2 outages in 5 days. The first saw users greeted with an empty timeline along with a welcome to Twitter message. The site itself appeared to be functional, could still be reached, trending topics worked, and users could still tweet, but the timeline did not render properly and was blank. This was followed 5 days later when a modification to an API prevented some users globally from accessing the service. Dish Network was also forced to pare back to only the most essential online presence when it became a ransomware victim, when they more or less fell off the internet for a period of time, appearing to cut off connectivity for all their services, both internally and customer-facing, before slowly restoring partial service and essential services. Looking at global outage trends, we also saw total outage numbers rise briefly before resuming their downward trend, while US outages increased consistently, accounting for 33% of all outages. And now let's dive in further. As always, I've included the chapter links in the description box below, so you can skip ahead of the sections to those that are most interesting to you. We'd also love you to hit like and subscribe, and always feel free to email us at internetreport@thousandeyes.com. We welcome your feedback and questions. And to discuss all of this, it's a great to have you back, Kamal. I think the last time we did this, we were actually filming a spontaneous episode from Cisco Live in Amsterdam, working out of a makeshift studio, complete with an upturned trash can and Coke can for counterbalance.
Thanks for having me, Mike. It's awesome to be on the Internet Pulse again. What a time at Cisco Live in Amsterdam. That was really fun and, crafty, I must say.
It was good. It was good fun. All right then, so let's take a look at the numbers this week. Global outages initially reversed the downward trend seen over the previous 2 weeks, rising initially from 316 to 337, which is a 7% increase when compared to February 20th, 26. However, that downward trend we saw before returned the next week, and where the global outages dropped from 337 to 271, a 20% decrease compared to previous weeks. Now this is what we're seeing typically. We actually kind of see this as a normal trend. If we go back to the previous year, this is what we're seeing, like a calendar trend coming across there. But this pattern wasn't reflected domestically. We saw the upward trend observed over the previous 2 week period, where it initially increased from 62 to 95, which is a 53% increase compared to February 2026. And this was followed by another rise from 95 to 105, which is an 11% increase compared to previous weeks. And this is kind of what I want to look at. Now, we've talked about this before, but where we saw the number of US outages rise, it normally impacts or reflects in the global outages we see coming up from there. But again, this is sort of the second week we're actually sort of seeing this happen. What this then means is that the US-centric outages account for a large proportion of it. So I have a theory about this, and my theory is that what we're starting to see is almost this control of the blast radius, as it were. So when we're doing some sort of change, and a lot of these, as we've talked about in the past, are maintenance engineering type of works because of the time of day they're done. We're actually seeing they're able to control this. We're not seeing so much of a domino effect. Like a change in North America, it's sort of the only way that's going to or has an impact that sort of directly flows down to the other parts of the world that then reflects in the global outages. Does that make sense, or am I sort of way off base there?
No, you are not. And to your point, it's actually quite good to see that, even though outages in US are rising, the global number is going down. To your point, it's a good and positive trend. It looks like people started, taking resiliency and change management procedure or operational excellence, for that matter, much more seriously than that was the historical case, right? So hopefully we see this trend, both for US and global going down. Ultimately we want to see this number as small as possible. But like being completely realistic, outages are going to happen. It's, to which extent they are going to happen, that remains to be seen.
But absolutely, to your point, outages will continue to occur, and hopefully what we'll see is that blast radius, that impact zone for necessary maintenance and engineering work continue to sort of shrink down as we're able to control it and keep it contained. Now let's discuss some of the outages from the past couple of weeks as we go under the hood. They do say beware the Ides of March, and although technically that's the 15th of March, we also saw some disruptions in early March this year, including Twitter. The first was on March the 1st, where Twitter users were greeted with an empty timeline and a welcome to Twitter message, as if they'd just set up the account and logged in for the first time. The site itself appeared to be functional. It could still be reached, trending topics worked, users could still tweet, but the timeline, which normally displays the recent tweets from accounts, users, and the following, did not render properly. It was blank, so you just got in that screen. But what I want to focus on really was a second outage that occurred 5 days later on March the 6th, when around 3:45 p.m. UTC, Twitter users globally began receiving HTTP 403 forbidden errors, which prevented some of them being able to access the service or click on links or tweets. So, Kamal, do you want to sort of take us through what we saw?
Absolutely, looking forward to it. So what we are seeing here is the application outages from our Internet Insights, and as you can see here, the Twitter outage was clearly captured on this view. So on the timeline, we can see that starting 16:45 UTC on 6th of March, the outage got recorded, and it lasted as visible here until 17:50 UTC. Now, looking at the different metrics, we can quite clearly see that approximately 100 servers or somewhere around that number were affected during this outage. And when it comes to locations, we can see quite interesting spread of these servers being located in United States, South Africa, Japan, United Kingdom, and other regions. In fact, if I switch over to the metric called locations, we are going to see that approximately 26 locations were affected globally. So we are here grouping by the applications, but we can do something similar to a server network, as part of which we can see that quite obviously Twitter autonomous system was affected. If we hover over this 147 number here and we click details of this, we can see that users, to your point, Mike, were getting HTTP 403s. In fact, like we show it as 4XX response code from majority of the agents that were affected. So this is what we saw in the Internet Insights, more specifically application outages part of it. Now we're going to share the page load test to see more details about this particular issue and how it looks from the performance related perspective from that test. Page load tests are actually the tests that are quite good at showing, user experience. So effectively, one of our software components called a browser bot has capability to execute page load tests, which is essentially simulating what user would do when they are opening the page. And we have transaction tests as well, as part of which you can quite easily script complete workflow. In this case, we are looking at the twitter.com as the target URL and page load view. And we can see that the metric that's selected is page load time. Now, looking at the event, you can quite obviously see that on average, it took like 3.91 seconds for the page load to complete for Twitter. And all of a sudden, when the outage struck, essentially, we can see that went to 450 milliseconds. Now, I'm pretty sure that a lot of people at Twitter would like to see this as a normal behavior, but unfortunately, we know that it wasn't the case. So that decrease in page load time, and again, this is a page load time across multiple different agents. So in fact, if I click here on the table, you can quite obviously see that this test is executed by tens of different agents, right? So on average, it takes approximately 4 seconds.
I think this is really important, and I do love the the page load test because it shows what the end users experiencing around from there. And you mentioned about the page dropping. So we now know that this was a change to an API across from there. But what we're seeing on there is that page isn't loading. So similar back to the one where we had the people getting the welcome page. What this is we get the connectivity coming in. So we actually see a connection point coming in, but then if I'm looking at that page load, it looks, all the green lights are on. I'm getting to the page. I can actually start to see stuff, but it just doesn't render properly. It just goes through and shows a partial one. I'm saying in this case, I think you can show this is what we see is that the 403s means we're actually making a call to something else, and that's some sort of authentication that's then being sort of knocked back. You don't have the authority to actually execute that.
Exactly. And to your point, and we spoke before about this as well, very often, regardless of what's the company that's affected by a similar issue, you start by asking yourself, is this problem with my infrastructure or it's actually somewhere else, right? And having this kind of view actually can give you a really quick answer to that question. Now, all of these agents at the same time, when they are probing application itself, synthetically, they are also trying to execute path visualization probing, as part of which we are trying to check whether there's packet loss, latency, or jitter. And then we are trying to visualize the path between the agents that are executing this test and the target itself. And as visible here, there was none of that, right? Which indicates that this was clearly application-related issue. There's no packet loss that would explain significant dip in availability, which further reaffirms our theory that this was 100% related with application itself having the issues rather than, network having the problems to reach the resource.
Yeah, and that's really good. And so just to emphasize your point there, why it's important to be able to see that whole exchange is because we can identify there's a problem on the network. So we're saying if there's a network issue, you just see maybe a high loss rate, you might have seen a break in that path or something down from there. But the fact we're seeing a 403 means we're actually getting a response, means we're actually sort of executing it from there, and then combine those two together, those layers together, so that complete service delivery chain. Because the fact then, so we know this was an API call. They've actually Twitter came out and said we made a change to an API and it had sort of these issues there. So we're calling a service. That could have been a third-party service for all we know. But what we're doing is testing that functionality coming through that system. Well, actually was a third party in some cases. So some of the people were reporting where they actually were going to sort of post or do things into another application, then they actually couldn't do that from a feed perspective. So yeah, important to see that service delivery chain.
And it's important to mention that HTTP server is essentially agent to server test, as part of which we are probing the target right from the specified set of agents in this particular case. And it's very important to mention here these two phases of the test: send and receive. Send is essentially the time it takes to send the first byte to the server, and receive is the time it takes to receive one. Now, if we saw the receive having the problems, we would straight away have a capability to say that potentially something on the return path was something that was problematic. So for example, we know that internet is asynchronous in its nature, so that the path that traffic takes on the way to the target is likely going to be different on the return path, right? Like essentially from the path that takes from the server to the agent that executed the test in the first place. So in this case, we see none of that. Like essentially, receive is completely green for every single agent, which indicates that everything from the network side was working fine. It's like purely HTTP related issue.
So that's great, Kamal. That was really interesting as we sort of went through there. So carrying on this minimalist theme, and what I mean by minimalist theme is what we had was when we on the Twitter one where we couldn't actually load a full page. So we could get to it, we could do it, but we couldn't actually functionally get to there. So what I'm talking about is I can get somewhere, I can't actually see everything that's going on. So unfortunately, Dish Networks was forced to pare back to only the most essential online presence when it became a ransomware victim. Detection, isolation, and containment are critical parts of security incident response, and these steps were clearly followed as Dish's issues unfolded. All right,
So what we're looking at here then is the I'm just looking at sort of the public facing the website for Dish around there, but this impacted all their internal systems as well as some of their customer facing ones. Yeah, basically what we said they did, and there's nothing wrong with what they did. They actually just turned everything off or removed their connectivity. But it's kind of interesting to actually look at what happens from there. So everything's going across quite nicely, and then as you were pointing out in the last one, so I'm looking here at a page load test. Everything sort of falls off a cliff, and then we actually get to that point where we get no connectivity coming across there whatsoever. Now, the difference in this one is that obviously this is a network related in terms of remove connectivity. I have my paths there, and then when I actually go across, I don't have any connectivity whatsoever when I get in there. So interestingly, you can see, and I'll go back into this where we start to see some of the systems almost start to recover because again, so I sort of fall off a cliff, light switch moment, things go off, remove connectivity from there. While my understanding is we actually go through and we look and we start to sort of clean systems up and go through that process there. But then we start to get some of them coming back online after this period of time. So we start to see from here, we can see obviously still a vast amount of them having connectivity issues, but we start to sort of come back on and get more connectivity. Again, I'm only talking to this front end system. Interestingly, when I start to actually see sort of what they were, when I look at those to go into that page load view as you were to see from the waterfall diagram, what I saw was quite interesting is that I'm having connectivity and I'm coming in, but all I'm doing is effectively just loading a logo screen. So almost like a test card from the old TV systems where I'm there just to sort of test the transmission there, which I thought was kind of interesting.
And the packet loss is actually quite interesting as well.
Yeah.
So if you look at that, it lines up with the moment that they started advertising again, or when they started being online, which is kind of normal. Even if you go back to HTTP server and page load, you can see like this really steps like looking recovery going up. So you can obviously see there. So essentially, imagine amount of traffic that hit the available resources at that time, right? It was probably a lot. So, this infrastructure for quite some time was probably being hit by multiple requests, probably more than it could handle at this time, until like more resources got spun up, depending whether they were on-prem or on cloud, or regardless in this particular case, right? But it's actually quite interesting exercise, and this is the example of the application that went off completely. Now let's gradually figure out what was happening. There was obviously remediation steps that were taken, and then you can quite clearly see that this step effect of, let's turn this up and then let's scale it up, as we go. And then you can see obviously full recovery. It's actually quite a good example on, what happens when these kinds of things happen.
Yeah, I like that. So it wasn't just minimal online presences that were observed in the past period. We also saw instances where either harm minimization was used or where it would have impacted end users by limiting the duration of a disruption. The first of these incidents, Akamai reported Edge Delivery DNS resolution errors on February 27th. This started around 7 p.m. UTC and with a total duration of around 20 minutes. So Kamal, do you want to just take us through what we saw?
Gladly, my friend. This is quite interesting event as part of which we observe it again, both in the Internet Insights, and we have a test that shows what really went on. But in general, it was a short event, much shorter than the last big Akamai outage that we extensively reported on. But here you can quite clearly see on the left-hand side, we have, again, regions: United States, United Kingdom, Australia, Germany, and you can quite clearly see that we have a lot of locations. In fact, if I click on the metric code locations, we are going to see that there were like 53 different locations across the globe at various times during this event, which means that this was a global outage. Now, it does not surprise. Akamai is one of the biggest, if not the biggest, CDN provider out there, right? They are very famous for their offline cache and what they do, and they are quite good at what they do. But when these things happen, they tend to affect a lot of customers, right, or users for that matter. So if you look at the right-hand side, you can see that Salesforce, Microsoft, SubConcur, Oracle, Walmart, US Bank, SAP, and other companies were affected. In fact, like there's a quite big list of them. This was a short outage, and likely majority of the customers that were affected by this particular issue were not like doing anything to resolve it. This got auto-resolved very quickly. However, last time Akamai had similar outage, it lasted 4 hours, right? And now very large financial customers were affected as well. We saw that in the data, right? And if you're a financial customer, you're gonna have regulators to answer your questions, like what's with your redundancy, like what's the full tolerance plan, and stuff like that. Those are all really hard questions to answer when you are getting pressed by the regulators, right? So having a plan for these kinds of things is really important. During the last Akamai event, I was actually studying it a little bit in more details, and there was quite clear distinction in what companies that handled this event did correctly versus these that were affected for a few hours. Right? So the companies that responded to this event had quite clear mitigation plan for this type of event. And it was fairly simple, in fact. If you think about it, Akamai not only does CDN-related stuff, they also do DDoS prevention-related systems, right? And, don't get me wrong, all other DDoS prevention companies and all other services similar to Akamai are prone to these things. It's just I'm not picking up on Akamai for that matter. It's
just an example.
Exactly. So essentially, what companies that responded to this type of the event correctly was just to stop advertising directly to Akamai, and in fact just use your regular transit, advertise it to the public internet, and from there. Yes, you're going to expose yourself to DDoS, but at least, what you're going to end up having is ability for your customers to reach you versus like
connectivity. Yeah,
exactly.
All right, that was really interesting. We could probably go on for way too long, but let's get to the final one. And with that, I want to selfishly return to Australia. Where Ticketek, who are an event ticket retailer, had an app reportedly failed to display the necessary ticket barcode. So the barcode on the bottom that you had to scan for entry into an entertainment venue. It was actually into the MCG, and it was to watch Ed Sheeran, if you want to be down from there. So what this meant was the tickets couldn't be validated. Now, the nature of the issue suggests it was a back-end problem, potentially connectivity related, because even the e-tickets that have been downloaded previously couldn't be validated. So it was actually that authentication part. So was this a real barcode, or was it someone who created around from there? And what it was doing was showing up as void or as an expired event, basically because of that connectivity issue. So that, again, was that back-end issue there. What I thought was brilliant was the response to this. So when they identified this was happening, what they actually did was they got people to, and I think it was sort of, I can't remember the exact numbers, but it was around 100,000 people, right, going into Ed Sheeran. Now, all of them, someone would have printed off their tickets previously, but a lot of them would have had them on the phone system. So what they did, they effectively mobilized all these printers and these people, and they had them going through and printing off the tickets. So even if we're talking sort of 20, 30,000 people to do this, they were able to identify quickly you had this issue, which was the this validation, which is the back end, assessed they couldn't resolve it in time to get people into the venue to see Ed Sheeran, and therefore then got this process in. And although there was complaints about people having a queue to get in from there, everybody got into the venue, everybody was able to see that. So I just thought that was a really brilliant example of identifying a technical issue and then implementing a remediation plan that was a physical process.
That's awesome. I mean, I'm glad that people got to see Ed Sheeran. That's the most important thing here.
The other point there as well, though, I guess, on the serious side of it is what this does highlight is that we're actually, again, the whole digitization of everything that's going around from there. We have e-wallets, we have sort of pay systems on the phone, all require this this validation system to go back and forth. Again, talk about these multi-dependencies. So, back to your previous point there, this visibility, being able to understand everything within our dependency, every dependency connected or not connected within that service delivery chain is now critical, and then having a plan to mitigate it. Okay, so that's our show. Don't forget to like, subscribe, and follow us on Twitter at ThousandEyes. As always, if you have questions, feedback, good, bad, or ugly, or references, pop culture references, I'll take them all. Or a guest you'd like to see featured on the show, send us a note at InternetReport@thousandeyes.com. So until next time, goodbye.